Students, in this video, I will be talking about the topic called as hashing. It comes under Module 5, Part 1, under the subject Data Structures and Applications. The subject code is BCS304. In this particular video, I will be talking why hashing is needed, what is meant by hashing, the advantages, the disadvantages, the applications, and some terms related to hashing and the different types of hash functions. See, when we are learning some topic, we always wonder, okay, for example, stack. Where is it actually used in real life application? We are learning a lot of things about stack, but where are we actually applying this? Right? So, in this video of hashing, I will be telling you some real life applications so that you can relate your topic with the real life example and you understand it better. Okay, so let us start with the topic of hashing. So, first of all, why hashing is needed? Okay, so think you're trying to create an email ID for yourself. Okay, you're giving sign up, you're entering some details about yourself, then you're asked to write your email ID and your password. Email ID and password. Okay, so you'll create your email ID and password. Email ID is still not that important, but password is very, very important and it needs to be kept very secure. Now, next time when you enter your password, see, you have created your password, you know your password, okay, fine. Next time when you try to log in, okay, you will be asked to input your email ID and password. How does the system know that it is the same password that you have created, that only you have entered, and all those things? How does this password get stored in the servers? How is this password stored in the server? Stored in the server. See, there are three ways of storing the password in the server. One is as a plain text. You can store it as a plain text. But what is the problem with storing the password as a plain text? If it is a plain text, then anybody who has an access to the server can get the information, right? Plain text means English like language. So anybody who can get the access to the server will be able to understand what is your password and they can misuse it. So storing your password as a plain text is not a good method. It is not advisable also. So what other method you can use? The other one is you can encrypt your password. You can encrypt your password. Encrypt means you give your password, then you use an encryption key, pass it through an encryption algorithm, and then you get the encrypted text. Encrypted text. And next time, if you want to get back your password, then you will have to use a decryption key. Decryption key, and then you will get your password, original password. Now, what is the problem with this method also, encryption? See, encrypted text might not be understandable by the user or the person who is getting the access to the server. But what if they get the access to the decryption key? See, using this decryption key only, they can get back the password. Original text is converted to an encrypted text, so it is not understandable. But what if they get hold of the decryption key? Using that, they can clearly get the password, isn't it? So there is still a flaw in using this encryption as a method for storing your password. Correct? Are you understanding? Why can't I make use of plain text? Plain text is easily understandable. That is why it is not a secure method. Why is encryption not a method? Encryption, you can encrypt a given text. Okay, but when you want to get back the original text, you want a decryption key. What if the person who is going to misuse your password gets a hold of this decryption key? Then he can apply it and he can get back the original password. That is similar to getting the plain text, right? So it is also of no use. So is there any other method in which I can store the password and it is not accessible at all? So this is where our topic comes in picture. The third way of storing the password is by using the method of hashing. You can hash your password so that it gets converted into a form that is not recognizable. So even if the person gets a hold onto your server and he gets the data, even then he is not able to make a sense out of it because there is no encryption decryption key there. So he can't go back and get the original text. So what you can do is you can have your password, you pass it through a hashing function, you pass it through a hashing function and get this converted text which is impossible for the person to decrypt or get back the original password from. So this is one of the securest method because you can't get back the original text once you have applied the hash function on it. So imagine you have converted and kept it in you have scrambled or something you have done based on the hash function. And after that, you're not able to get back the original text. Then it's of no use, right? For the person who is going to misuse it. So he might get a hold of it, but he can't make sense out of the text that you have converted. So this is a more secure way. So when you're trying to create a password, now you understand one real life application. When you create a password and you want to store this password in the server, this is one of the applications of hashing. You can convert it into a text that is not recognizable and store it in the server. Are you understanding? So this is how hashing can be used. One of the uses of the hashing. Okay. Now let us look at the let us look at the definition of hashing. See, many definitions are there. If you look at your textbook or if you look at your notes and all that, many complicated definitions are there. Let me give you the most easiest one. So if you have understood about that password saving, so from that you can relate to this definition. So let me write the definition. Hashing is a process. Hashing is the process of scrambling. Hashing is a process of scrambling or converting a piece of information. A piece of information. This information can be of any type. It can be a text, it can be an image or anything. Okay. Into an unrecognizable form. This is the definition in a very simple, easy terms. Into an unrecognizable form. Okay, so you're converting your original text into some form that is not recognizable. So many questions arise. If I am converting into an unrecognizable form, then how will I get the original text? All these questions you might get, right? So slowly throughout the video, we'll discuss about all of these things. Okay. Now, let us take an example of that same creating password and we'll see how the hashing can be used. See, first time when the person creates an email ID and the password, what you can do is you can apply some hashing function on it. It's an algorithm basically or a method. Okay. So method and you will get the hashed value of it. Okay. You will get the hashed value of your password. Means some converted text. Next time, this is how it will be stored in the server. It will be stored like this in the server. Next time this is when you create the password. Next time when you try to log in, so you will enter your email ID. This is when you try to log in. Okay, you will enter your username and password. So what happens is again, your password will go through the hashing function. And again, you will get the hashed value. Now, this hashing function should be the same. Okay, it should be uniform. While you create whatever hashing function you have used, that same function has to be used when you try to log in the next time. Now, what happens is here there is one that is just created and the one which is already created when you set up the password. Now, what happens is these two will be compared. These two will be compared, and if they match, then you will be allowed to log into the given website. This is how it works. So when you create, your hash function is created and it is kept. Next time when you try to log in, again your login details, your password will be again put into the hash function and it will give you the hash value. So what happens is the already created one will be compared with the hash value that you have just created. Okay. So that is how the comparison will take place. And if there is no mismatch, that means it's the same and you will be authenticated and you will be allowed to log into the website. Are you clear? So this is how hashing works. Okay. Now, how can you relate? How can you tell the difference between this and encryption? And encryption also, the text is converted back in, it is converted into an unrecognizable form. In hashing also, the text is converted into an unrecognizable form. Now, how is it two different? The most simplest is, I think, when you attend the interviews, this is the most common question they ask. How is encryption and hashing different? So what you can say is, in case of encryption, when you apply the encryption key and you get back that scrambled text, if you want to get the original text, you can apply the decryption key and get the original text. Whereas in case of hashing, once you apply the hashing function, you will get the scrambled text and there is no way to get back the original text. So here the change is irreversible. In case of encryption, the change can be reversed. From the scrambled text, you can get back the original text. Whereas in case of hashing, once you scramble the text, you can't get back the original text. That is why it is very secure, right? So there is no way of getting the original text. Your data is still secure. Okay. Now let us look at the advantages of hashing. See, in your syllabus, basically, this is not a separate topic, your advantages. But when we learn a topic, we it is better to always know the advantages of a given topic and also the disadvantages. So I'll list out the advantages and give you some real life examples so that you can understand. Mm. First one is first one is fast data, fast data lookup. Fast data lookup. So what does this mean? It means that hashing allows you to quickly access the data, making it ideal for the applications such as search engines or databases, where speed is crucial. See, faster data lookup means you can easily access the data in very less time. When you have a lot of data to be you have a lot of data, and out of that, if you want to get a particular data, using the hashing, the lookup becomes easier. How? Let me explain with the help of an example. Suppose you have a library. Okay, you have a library, and in that library, let's say you have 10,000 books. Okay. What you can do is, suppose I want to search for a book, one book. Out of these 10,000 books, I want to search for one book. So what I can do is, one way is I will have to start serially. So one after the other, I will take out the book from the shelf and I'll see, okay, whether it is my title. No, it is not. Then I'll keep it back. If it is my book, then I'll take it. Now imagine what if out of the 10,000 book, your book is at the 9,999 position. So from the 1 till 9,998, whatever you have checked is of no use to you. But you had to check because you're not sure where it is placed. So you will go through all the books till you get your own book, right? But it is time consuming. There was no use to go through all the books, right? So what you can do is, instead of checking all the books one by one, you take the title of the book. You take the title of the book, you apply the hash function on it, you take the title of the book, apply the hash function on it, and store the book in that order. For example, all the books having the title starting with the, you hash it and store it. So next time, okay, all the books will be stored here. All the books starting with the great will be stored here. So next time you want to search a book which starts with the word great, you need not go through the other books. See, comparatively, the search becomes easier. I'm not saying that the search will be completely eliminated, but you see, I can directly go back, go to that part where the part is hash, right? Great. So I can go there itself. There's no need to search in the other parts, this part. So we can say that the data lookup is very fast if you make use of hashing. Okay, I hope you are able to understand. Hashing allows you to quickly access the data because we can hash the given data and keep it. So next time when you want to access a given data, you need not go through the entire documents or entire list of information. Instead, wherever this hash value is generated for a given required text, you can go there itself. I hope you are clear with it. Next one is data security. The next advantage is data security. This, I think, you are able to understand why data security is advantage of hashing. I told you when you want to apply a hash function on a given text, it'll get scrambled up, and next time anybody who wants to get access to your values will not be able to understand. So it is of no use to them. If they're not able to understand, it is of no use to them. So that is why the security is more when you apply the hashing function on a given set of data. So data security is more. So you can give the password itself as an example. So once you create the password, you store it in the server. So anybody who wants to access your data, they might get hold of that scrambled data, but it is of no use to them. So the data security is more. I hope you're able to understand. Next one is efficient storage. How is efficient storage an advantage of hashing? Efficient storage. Data storage, okay. So hashing helps organize the data into a structure that stores and it saves the space and makes the retrieval much more efficient. So it will help you to store the data such that, okay, it saves the space. Also, it makes the retrieval much more efficient. Now, how is this possible? Let me show you again with an example. Suppose I have a post office, and in the post office they might be receiving some letters, they might have to send out some letters. So what you can do is, see, all the letters would be put up into different mailboxes like this, right? These are the mailboxes, okay, mailbox. So every letter you'll place it in one mailbox. For example, all the mailboxes for let's say a person called as Kiran, I'll put it here. His mailbox it is, and some other mailbox, let's say Pooja. So one mailbox dedicated to her, I'll keep like this. So for a town, you imagine how many mailboxes are needed. So what you can do instead of doing this arrangement is, you can have mailboxes arranged according to their alphabets. This is one arrangement, okay. You can have mailboxes arranged according to their alphabets. So all the persons whose name starts with A, they have this mailbox. Likewise, B and so on. So next time when you want to get the information of someone called as Aisha, okay, I want to search a mail that has been received for Aisha and I want to give it to her. Now I don't have to go through the other one because I know that this, all the names belonging to letter A is put into a separate mailbox. So if you see, it is saving the space also. So all the names which is starting with letter A, let's say Asha or Aisha, okay. Aisha or Asha. 1 minute, okay? Just a second, okay? I'll pause and come back. Sorry about that pause, okay? So that is what. So three users are there. One is faster data lookup, the other one is data security, and the other one is efficient storage. So even if in the interviews, if they ask you what are the advantages, you can give these real life examples and also tell about the advantage. So let me summarize the advantage. There are three advantages. So one is faster data lookup. So because you will hash a given data and put it into a given hash table, so you can just know the hash function and also the values, and you can easily retrieve the data. So data lookup becomes very fast. Also data security. Once you have converted a given text using the hash function, there is no way you can get back the original data. So someone who tries to get your data also, they will not be able to understand your text. The third one is efficient storage. Efficient storage, it will help you in store your data in very less space. Also retrieval becomes very fast. How can you justify this point? You can give the example of this mailbox. When you have a post office, for each user, if you keep a separate mailbox, imagine the amount of space you need. Instead of that, you make sure that all the people having the letter A, you hash their names and put it into the same mailbox. So the next time you want to get a person whose name is, um, what you call that, let's say name is Jack. So next time you need not go to A, B, C, D. You directly know that it is Jack. So it will be stored in the mailbox where all the J letter names are stored. So you'll directly go there. So that is the advantage. I hope you have understood. If you want, to take a screenshot of this and then learn it properly. Okay. Let us look at the disadvantage. So disadvantages. Again, I have selected three important disadvantage. The first one is hash collision. Hash collision. Okay. So what do you mean by this? The first disadvantage is hash collision. See, a hash collision happens when two different pieces of data end up with the same value. What do you mean by this? Two different values and they end up with the same hash data. See, let me give an example. Suppose there are 10 students. Okay. Suppose there are 10 students. And you, being the class teacher, you are giving them tables to sit in the classroom. So let's say this is the table, like this. Some tables are arranged, tables and chairs. Okay. And you are making them sit. So let's say S1 wants to sit. I have given the space for I, being a teacher, have told that S1 you sit in this particular space. Okay. Let's say S2 will sit here. And let's say S3 will sit in this particular desk. Yeah. Now, when I come to S4, S4 says that I also want to sit at the very beginning. I don't want to sit at the back. So he says that give me either 1, 2, or 3. No, even better, he says that I want to sit in the first place, in this first desk itself. Now you see that 1 is already occupied by student 1. So how can 4 sit in that place, right? So that is the hash collision. The data is already present in the given index in the hash table, and some other value, when you calculate its hash value, it is also pointing to that same index. So next time, when one value is already present in that particular index, how can you put another value over there? So that will lead to something called as hash collision. That is the greatest disadvantage of hashing. You put the data comfortably, okay, you're okay, this is irreversible, so it is very safe, so I'll make sure that this particular data stays over there. What if some other value, when you calculate its hash value, that is also pointing to that same location? Then you can't overlap, right? You can't overlap because one data is already present, you can't put one more data in it. Neither you can accommodate two data in one index itself. It is not possible. So that will lead something called as hash collision. So you can relate, you can remember this example and then you can explain this point. How collisions are happening in case of hashing. So one student wants to sit in the desk, you comfortably make them sit. When the second student also wants to sit, it is impossible for them to sit there because it's already occupied by someone else. So same thing can happen in hashing. When you give your data to a hash function, your hash value will be calculated and based on that your value will be placed. Now for some other data also, if you get the same hash value, then since the data is already present, you can't place one more data. So that will be leading to hash collision. I hope it is clear. The next one is irreversible. Irreversible. Next disadvantage is irreversible. Let me tell you how this works. So, hashing is a one-way method, right? So, once something is hashed, you can't get the original data back. This will be problem when you want to get some original data. Suppose some important information about a student has been kept somewhere. It has been hashed and kept. Now you have lost the original data. You only have the hashed data. Then how can you go back and get the value? Not possible, right? So that will be leading to a disadvantage called as irreversible. You have taken some student's information and you have passed it through a hash function. You have passed it through a hash function and you have get the hash value. Next time you want to get the original, you get the hashed value and you have stored it in the hash table. I'll explain these terms in detail, so you don't worry. Okay. So next time if you want to get back the original value, it's not possible because the process is irreversible. I hope it is clear. The third one is, this is very interesting. Fixed output size. Fixed output size. What does this mean? See, suppose I have two files, and suppose I have two files. One file, let's say, is of 5 MB. The other one is of 32 GB, for example. Now I want to hash this and I will get the hash value. See, when you apply a hash function, you will get the hash value, right? Let's say here the hash value is fixed. It will be of, let's say, 40 digits, not 40, let me say 16 digits. This function, when you apply on a given data, you will get a hash value which is of 16 digits. Now the file is only of 5 MB. Okay, the first file is only of 5 MB. So let's say I'm getting the hash value as 1, 2, some value like 1, 2, 3 at A, something like this. Similarly, when I apply the hashing function on this 32 GB file, I'm getting the full 16 digit, hash value. Let's say like 1, 2, 3 at dollar, like this, all the 16 digits. Now you see, in the first case, the file was very small. So the hash value of that file is also small. It is only having 5 digits. See, 1, 2, 3 at 10 A. Whereas in the second one, it is justifiable. See, file is very big, 32 GB, and I'm getting the hash function of 16 digits long. In the first case, what has happened? The size is very small of the hash value, but you have allocated that many digits for it. What about the rest of the spaces here? Rest of the spaces here, it is getting wasted, isn't it? Because of this particular point saying that the hash value will be of a given size, exact this number only. If it is not of that value, then some spaces will be wasted. So that is why this is the disadvantage of hashing. So, what are the disadvantages? Let me summarize. When somebody asks you, what is the disadvantage of hashing? You say that the first disadvantage in case of hashing is it will lead to collisions. That is, when some value is already present in the given location in the hash table, if the some other value also gets the same hash value, so it will be trying to access that location where the data is already present. So that will lead to collision. The second point is irreversible. Once you have applied a hashing function on a given data, if you want to get back the original data, it is not possible. That will lead to that irreversible disadvantage. The third one is fixed output size. When you apply the hashing function on a small file and you apply the hashing function on the large file, because the output size is fixed. In the smaller file case, your hashing value will be of a smaller value, but because our fixed size is given, the other spaces will become waste. That is what the disadvantage is. I hope you have understood and you will be able to read it. Okay. So you take the screenshot of this hash collision, irreversible, and fixed output size. For the campus placements also, if they ask, you can explain this with the example. Okay. Next one is applications. This is the most interesting part. Where is it actually used? Where is it actually used? This is very interesting. One is in password, obviously. We have discussed so much about it. So, first one is password security. And the other one is you can use it in databases. So, data storage and retrieval, if you want to do. In case of database, you can make use of this. Third one is file integrity checking. I'll explain this. File integrity checking. Now, what does this mean? See, when you are downloading the files from the internet, how do you make sure that they are not some corrupt files or they're not, something which is leading to hacking or something like. So, what you can do is when a file is getting created, they'll create a hash value for it. When you're trying to download it, it'll calculate before downloading, you can calculate the hash value. If it is an authentic file, then when you created whatever hash value you have got, will be same as the one that you will get when you download. So you can compare and make sure that it's an authentic file. So in that case, we are making use of file integrity checking in hashing. Okay. Next one is URL shortening. It is used in URL shortening. So, have you noticed something like this in your web browser when you input your website? Have you seen instead of this, you will have something like HTTPS? Have you noticed this? This bit.ly. You are getting confused. I have input my valid website. Why is it showing bit.ly? It is to make sure that smaller the given website name is, faster, it is faster only, right? The processing. That is why we do the URL shortening. That is one of the applications of hashing. And the next one is it is used in digital signature. It is used in digital signature and blockchain. See, when you do this Bitcoin transactions, right, it is highly susceptible to hacking, right? This Bitcoin transaction. So, what you do is when you do a Bitcoin transaction, you hash it immediately so that it is hashed. And next time, the same thing, if you want to access the same transaction, you can't, really get the access because it is already hashed. So, you know that, okay, that transaction has already taken place so that nobody can misuse your transactions. So, that is what is one of them, one of the applications. So, in digital signatures and blockchain. Okay. The next one is this, I think, is the last one, but very interesting one. That is caching in web browsers. Caching in web browsers. Okay. What does this mean? Suppose I'm always going to this site. Okay. And I want to buy this particular pair of shoes. So I'm accessing it again and again. I will put it into the cart, but I'm hesitant whether to buy or not. So next time, after some time again, I'll access. I'll go to Amazon.in, then access those pair of shoes I watched. Then I'm like, should I buy? Or will the price get lowered? Some thought like this. So what you can do is instead of going to the see when you visit a given site, there are complex images, there are a lot of text involved, so bandwidth used will be more, right? So every time the server will go, it'll access that particular web server, get the data back to your system. All this happens. So if the system knows that this is a particular website that you are accessing again and again, instead of downloading the things from the from the web server again and again, this frequently accessed particular website and its contents can be hashed and kept in your cache. So next time you want to access Amazon.in, Amazon.in data is already cached and kept. So it can be directly taken from the cache instead of going to the web server and bringing back the data from there. So faster retrieval of the data. So here caching in the web server, web browser is also one of the applications of hashing. See some of the real life applications. Now are you able to relate the hashing with the real life example? So next time if they ask, oh, where have I learned this and where am I going to apply? Say in hashing, these are the applications. So password security, data storage and retrieval, file integrity checking, URL shortening, digital signature and blockchain, and caching in the web browser. These are some of the applications where hashing is very much used. Take a screenshot of this and learn this. It will be helpful for your placements as well. Okay, I hope you have taken. Let us go to the next topic, that is just a second before the next topic. Okay. So we'll go ahead with the topic. Next is you have looked at hashing, advantages, disadvantages, and applications. Now we will look at some of the terms involved in hashing. Some terms. These are very important. One is your hashing itself. By now you should know what it is. So some other terms are keys, then hash table, hash function, and hash value. Many students get confused with these terms. So let us explain with the help of an example. So hashing is a process. Correct? It is a process. What is a key? Key is the data in very simple terms. If I have to explain key is a term. Key is a data that you would like to store in the hash table. So those are called as key. Okay. And when you do the hashing on a particular data, your data that gets hashed will be stored in a table. Here, your data will be stored. Data as in your keys will be stored. It's a table where your keys will be stored. Hash function can be a method. This method will be converted into an algorithm, and you apply this particular method on the keys, and you store that information in the hash table. Hash value, in very simple terms, I can explain it as an index of the hash table. This value tells where exactly you have to place your converted data, where exactly you have to, not converted data, where exactly you want to place your data in the hash table. See, for example, you have your password. You take that password, pass it through the hash function. So your password is the key. Okay. So you pass it through the hash function. You will get something called as hash value. Hash value is the index. And based on this index, you will have a hash table, and it will have some partitions like this. So based on this index, you will place index as in your hash value. You'll place your data over here. Let me show you with the help of an example. Suppose I have a password called as 123 at ABC. This is my password. I will pass it through a hash function. Okay. Here I have my hash table. My hash table will have these memory spaces, and I will have these indexes 1, 2, 3, 4, 5, and 6. These indexes are the hash value. No, sorry, it is not the hash value exactly. I'll keep it like this for now. Now, when you apply the hash function on this 1, 2, 3 ABC, you're getting the value, hash value as, let's say, 5. You're getting the hash value as 5. This is the key. This is the hash value. Now, what happens is, it has come to know the hash value as 5. So, in this fifth index, this particular value will be stored. 1, 2, 3 at ABC. Are you understanding now? So hashing is the process. Key is your data. Hash table is the data structure where your data is getting stored. And hash function is a method which will help you to convert your given text into a unrecognizable form. And hash value is sort of an index of your hash table where you can store your given values. Okay. Next time when you want to retrieve the data, you need to know only the hash value. So from 5, if you know, okay, 5, then from 5, you can get back directly the password. Okay. So let us look at the formal definition of this. Okay. So what is meant by hash function? So hash function is a function which is used to put the data in the table. Okay. Hash function, let me, I think, give you the definition also. Hash function. Okay. So this is very important because this is commonly asked. Hash function is a function which is used to put the data in the table, and it will return an integer called as a hash key. So when you have the data, you apply this hash function on it, hash function, you will get your hash value. This is an integer. And this commonly asked question is, what are some of the good requirements for a hash function? How can you say if a given hash function is a good one? Okay. So the first one is, okay, how do you make sure your hash function is the best one? Or you can say if it is the best one, that is, a good hash function should generate the hash addresses such that the keys are distributed as evenly as possible among various cells of the hash table. See, here you are having this hash table, right? And you are having these indexes, right? These are hash values, indexes like this. Okay, 1, 2, 3, 4. These can be considered as your hash values. Now, what happens is your hash function should be capable enough to generate these hash values so that no collisions occur. So that is one of the first criteria. If you are able to generate unique hash functions, unique hash values, so that there is no collision happening, then you can say that your hash function is a good one. Okay, most of the time this can be achieved, but of course it has its own flaws. Okay, so you can say that a good hash function, I'll write down, a good hash function should generate hash addresses such that all the keys are distributed as evenly as possible. Okay, sorry, as evenly as possible among various cells of the hash table. Second one is the computation of this hash value should be easy. So your hash function should be, it should be able to generate hash function within few steps. It should be less complicated. And generation of the keys should be complicated. And generation of the keys should be a simpler process. Not keys, actually, values, hash values should be a simple process. If these two conditions are satisfied, then you can say that your hash function is a good one. Okay. Let us go to the next topic. That is, this is very commonly asked question in data structures, that is types of hash function. Types of hash function. So you have to listen to this very carefully. You can listen to this nicely and understand this. There are different types of hash function. One is your division method. Division. Sorry, here I've made a mistake. Division method. Wait. Division method. This is the first one. Let us learn how this works. See, here what happens in case of division method is division. Okay, so you're taking your given keys and you're applying some sort of a division method onto it in order to get the hash values. What is the main function of the hash function? It is to generate the hash values. Now using the division method, you can achieve it. So it goes something like this. In order to get the hash value of a given key, okay, or how the calculation goes, it is your key modulus the total size of your hash table, the size of the hash table. Okay, this is how you can apply the division method. This is sort of a formula. You can remember this. Okay, how to get the hash value of a given key? It is key modulus, or you have to find the remainder of key divided by the size of the hash table. Let us look at an example and then you can do it. Suppose the problem goes something like this. Store the records 54. Are you able to understand? This is 54, 54, 72, 89, and 37. These are the records in a I want to store these records in the hash table. Assume hash table size is 10. Okay. So they have given the keys and all that. So now you can store that in the hash table. So what is the formula? Hash of key is equal to key mod size of the hash table. So first I'm finding the hash of first value, that is 54. So it is 54 mod 10. So it is like this. Okay. 10, 54. So 10 times 5 is 50. So you're getting the remainder as 4. Now this remainder will be the answer. So it will be 4. Likewise, for hash of 72, you're getting the value as 2. Then 89, you're getting the value as 9. And the last one is 37. So you're getting the hash value is 7. You have to divide it by 10 and then, get the remainder. Now, is it always 10? Is this value always 10? No, it depends upon the size of the hash table. If the hash table size is 50, then it is 54 mod 50. If the hash table size is 25, then it is 54 mod 25, like that. Now, once you calculate the hash values, you draw the hash table like this. This is your hash table. It says the size is 10. Remember, the size is 10. So, we'll write the indexes for it. So, how do you know the indexes? See, if the size is 10, okay, that means the indexes can go from 0 to 9. 10 partitions sort of. So, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. Now, it says for 54, it is 4, right? So, place 54 in the 4th place. Like 72 in 2, 89 in 9, and 37 in here. Like this. This is how you can do the division method. Okay. First you calculate the hash values, and based on the hash values, you place the given keys in the hash table. Now, this is how you do. What if there was one more value like 47? Then what would be its hash value? It is 47 mod 10, which is again 7, right? 47 mod 10 is 7. Now, if you look here, this is where I'm supposed to place this value, right? At the seventh hash value position. But the problem is seventh position already has that 37 value. So this might lead to something called as collision. In the later videos, we will learn how to do the collision handling. But for now, you remember, this is how you do the division method. You take a screenshot of this, then you can try with some other values. Let me give the values. Let's say 30 to 25, 46, and 75. 75, no, it might lead to, I'll give you the easy one, 73. We'll assume the hash table size is 20. Do I have to make it so complicated? No, let's keep it as 10 itself so that it becomes easy for you. Okay. So you solve this example. Okay. These are your keys and the hash table size is 10. Okay. You can take a screenshot of this and then you can do the calculations. That is the first method, division method. The second one is mid square method. Mid square method. Mid square method. Okay, mid square method. Let us look at the steps. I have made it into steps so that it becomes easy for you to understand. Okay. Suppose the steps. Okay, the first one is square the value of the key. Square the value of the key, that is key is k, and find k square and get k square. You square the value of the key and get the k square. Then second step is, I'll explain all this, okay, with the help of an example. Extract the middle r digits as the hash value. You might get confused. What is she saying? We'll look at an example. So I'll take the example as let's say the key is 1, 2, 3, 4. Okay. Key is 1, 2, 3, 4. And let's say my hash table size is 100. Now I want to store this single value 1, 2, 3, 4 into the hash table, which is of size 100. Now, how do you do this? See here. Step 1 says you have to square the key. So it is 1, 2, 3, 4. You have to square it. So it is 1, 2, 3, 4 times 1, 2, 3, 4. Do the calculation. So I'll give you 1 minute. Pause the video here and do the calculation and tell me how much is 1, 2, 3, 4 times 1, 2, 3, 4. I'm getting this answer. So check if you're also getting the same answer. Okay, that is step 1. Now, what it says is extract R number of digits from the hash value. So you are getting the value key square, that is your hash value. So your key square you're getting as this one, right? From that, you have to extract R digits. How do you extract R digits? See, the extraction of the R digits depends upon your table size. Table size. See, for example, if the table size is 10, if the table size is 10, then I can have indexes from 0 to 9, right? So you have to take the highest number of digits in that index, and that will become your R value. So in this 9 is a single digit. So this becomes only 1. Suppose I have 100 as a size of the hash table. 100 as a size of hash table. So the indexes will be from 0 to 99, right? 0 to 99. Size is 100, so the index will be from 0 to 99. So you have to take the highest. See, 0 means single digit, 99 is having 2 digits, right? So the R value is 2. Likewise, if the index is of, let's say 2000 positions, I have not index, sorry, hash table size is 2000. So if it is 2000, how can the indexes go? It will be from 10 to 1999. Correct? So 0 is a single digit, but you will have to look at the more number of digits, which is having more number of digits. So 1999 is having 4 digits, right? So the R value is 4. Now in this case, this problem, hash table is how much? Hash table is 100. So it is from 0 to 99 index. So the R value is now 2 because 99 is having 2 digits. So you will have to extract. Now what you will do? See, from the left and right, try eliminating 1 digit each. So I will eliminate this. Then I'll eliminate this. I'll use a different color. So I'll eliminate this and this. I'll eliminate this. 2 digits, right? So I'll have to remove 2 digits. Okay, sorry. So it is 1 and 5 here. Confused, you shouldn't get. Okay, 2 digits you will have to remove. See, it says 2, no? So remove. So 1, 2. You can remove 2. So better, I think it's better to remove one at a time. So remove this, remove this, remove this, remove this. Still there are 3 digits left. It says remove. Now you see here. If I remove this 2 and also remove 7, okay, if I remove 2 as well as remove 7, then I'll be only left with the 2 single digit. But it says that R should have 2 digits as per this example, right? So what you can do is you need not eliminate this. Okay, either you can keep 2 as it is and involve this one, the letter previous to it. Or you can keep 2 as it is and involve 7. So you can have the hash value as either 22 or 27. Usually we take the left side one. So you can use 22. Are you understanding? What you have to do is based on the R size, you will have to retain that many number of digits from the squared number. Now, if it is an odd number, you can't really remove, no? So, in this case, your R value is of 2 digits. So, when there is an odd number, if you remove, you are only left with 1 digit. So, you can keep that 1 digit and take one letter before. I'll do one more example so that it becomes clear. Okay. Let me take the key as 2, 3, 4, 5. And let me give the hash table size as 100. Again, it is from 0 to 99. So R has to have 2 digits. Remember. Now, first step is step 1, where you will have to find the key square, which is 2, 3, 4, 5 square. The answer that I'm getting is 5499025. In the step 2, you have to get the digits based on the R value. So remove 1 from the left, from the right. Now again, it says 2 digits. So either it can be, see here, either you can keep this 9 as it is, because if you remove this 9 and 0, then you're only left with the 9 only, no? So either you can keep 99 or you can keep 90. So 99 or 90. So when you have your hash table, so it will have 0, 1, 2, like that till 99. So you can put your value, that is your key 2, 3, 4, 5 in this particular position. This you will have to show, okay? I forgot to show it in the previous example. So it will be like this, hash table. So 1 minute, okay? Just a second, okay? Okay. So that is all about the second method, that is uh, mid-square method. I hope I've written the name mid-square method. First method is division method, then you have mid-square method. Now looking at the third method. Third method is called as folding method. They will ask you this particular question: what is meant by a hashing function? What are the different criteria to decide a good hashing function? And explain the different types of hashing functions with examples. That time you can answer this one. Okay. Third one is called as folding method. Okay. So here also I have divided into two steps. So step 1 is you have to divide the key value into equally equal sized parts. If you have a key k, then you divide it into different parts like this, up to kn. Make sure that you try to place it as equal as possible, like all of them. If it is a 6-digit number, then you divide it into 2, or 3, like that, something like that. And step number 2 is you have to add the individual, 1 minute, you have to add the individual parts. That is, sum is equal to k1 plus k2 up to kn. Okay, now let me take an example. Suppose the key is 1, 2, 3, 9, 8, 1, 2, 3, 9, 8, 7, 2, 3, 4, 8, 7, 6. This is the key. And I want to store it in the hash table of size equal to 10. Okay, hash table size is 10. What you can do is, in the step 1, you divide it into equal size parts. Now you might wonder, like, equal size parts. What is that equal size? Is it like everything should be 2 digits? Is it like every part has to be 3 digits? That can be decided by you. See, let me count the number of digits. Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 digits are there. So divide it into equal parts. So I can divide it this one can be of 2 digits. So I can have 1, 2, then 3, 9, then 8, 7, or so on. And or I can have 1, 2, 3, 9, 8, 7, 2, 3, 4, and 8, 7, 6, like this. Or I can even have one, just a second, 12398723, like this. You can have the partitions based on your convenience. So I will take 2 digits each. So it is 123987234876, like this. In the step 2, you will have to add them. So it is 12 plus 39 plus 87 plus 23 plus 48 plus 76. Add, you're getting the value is 285. Now, this is the hash value I have got. Okay. Now you see here, the hash table is of the size 10. So hash table will have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. The value I have got is 285. If you remember, where is 285 hash value over here? It is only having between 0 to 9, isn't it? In that case, you will have to apply that division method like this under this only. So it is 285 mod 10. So it is 285 mod 10 is 5, right? So you can place this entire thing, that is 1, 2, 3, that entire number in this fifth position like this. I'll take up one more example so that it becomes clear. I'll take the odd digit number this time. Okay. In the example 2, let me take the key as 2, 5, 3, 8, 6. Now this is the key. Let's say the hash table size is 10. So hash table will be like this: 0, 1, 2, 3, up to 9. Now I have the key like this. So first thing is, in the step 1, you will have to divide it. Now how will you divide it? See here, if I take 2 digits, okay, so it is 2, 2, 5, 3, 8, and 6. Even if I take 3 digits at a time, it will be 2, 5, 3 in one and 8, 6 in one. So what you can do is, in case of an odd digit, if the last digit is not becoming the part, it is remaining as a single digit, it is fine. Others, you divide it into equal parts. So what I will do is, I will take 25 as one part, 38 as one part, and 6 as one. So step 2 is 25 plus 38 plus 6. So can you tell me how much is 25? 25 plus 38 plus 6. You're getting the value as 69. Now 69 again is not a valid position here. You can only have from 0 to 9, right? So 69 mod your hash table size 10. You're getting the value as 9. So 2, 3, sorry, 2, 5, 3, 8, 6 would come to this place in the hash table. I hope you are clear with this one, folding method. Okay. You can note down the steps and then you can learn. And the fourth one and the last method one is by converting keys into integers. This is mostly applied on string type of data, alphabets. Suppose I want to store the key hello. This is my key and I want to store this in my hash table. Let's say my hash table is having the size of 10. So hello I want to store. So what you have to do is, first what you do is, you take the each character separately and find its ASCII code. ASCII code. So ASCII code of, if you remember, for capital A, I think it is 65, and for small a, it is 97. From there, it continues like this. So if capital A is 65, then capital B is 66, and so on. So likewise for H, I'm getting the value 72, 101, 108, 108, and 1111. So can you calculate for this one? It is 72 plus 101 plus 108 plus 108 plus 111. So I'm getting the value is 500. Then see, your table is having from 0 to 9 only, no? 0 to, sorry, this is your hash table. So 0, 1, 2, up till 9. So what you do is you take this value 500, again divided it by 10. So you're getting the value 0. So that will be stored over here in the 0th position. So I hope you have understood. Let me do one more example. A, B, small c, capital D. This is small c, okay? So ASCII value of A is 65. Then this is 66. ASCII value of small c is 97. D is 68. Okay, so because A is 65, no? So B is 66, like this. Similarly, small a is 97. So it is not 97, it is 99. Because if A is 97, then B is 98 and small c is 99. So let us do the calculation. So it is 65 plus 66 plus 99 plus 68. I'm getting the value as 298. Let's say the hash value table is having the value 100. So the values can go up to 0 to 99. So at the max, you can have 2 digits. So your hash table will have indexes from 0, 1 up to 99. But it says 298. So you divide it by the total size 100. So 298 mod 10. 298 mod, not 100. So 298 mod 100. 2. So 200. I'm getting 98. So in the 98th position, you will have to place this. You will have to place this A, B, C, and D. Like this. This is how you will do the fourth method by converting the keys into integer. So there are 4 methods. You will have to learn the methods because that is the most commonly asked question. So this comes to the end of the video. So in this particular video, we have looked at why hashing is required, what is hashing, advantages, disadvantages, applications, all the important terms involved with hashing. And lastly, we looked at the types of hash function. I have discussed it in such a way that it is simple and you're able to understand, and also you're able to apply it to the real life applications. So go through the video correctly, take up your own examples and learn. Okay. So in the next video, we will discuss the next part of hashing. Okay. I hope you have understood the video. Okay, learn it correctly. This will help you for both exams as well as interviews. Thank you so much.